Here we are, back for more action. So we're going to look at permutations involving identical objects. So if we have a set of n objects containing A identical objects of one kind and B identical objects of another kind and so on, this can be arranged in n factorial divided by A factorial, B factorial ways. So really, the denominator represents removing the different identical objects. So, for instance, if I have the word Bob, so here I'm just going to make one Bob, but I'm going to switch the B's around. Oh, wait a second, it spells Bob again. So B and B are identical objects, so we must be able to discount those. And since there's two B's, there'd be 2 factorial ways that we can organize those B's. So we would have to factor out by a factor of 2 factorial since there's 2 identical objects of B. This is just saying it's expanding it for identical objects, A of one kind, B of another, and so on. So I'm going to take a look at the word aardvark. Identify the number of different 8-letter arrangements that can be made using the word aardvark. Now, aardvark is a weird word, and perhaps the first thing I'm going to do, I'm just going to rewrite it in terms of letters. So it looks like I have 3 A's, I have a D, I have 2 R's, a V, and a K. So aardvark 1, 2, 3, 4, 5, 6, 7, 8. Good. So I have 8 letters in each. And what we see is I have 3 A's and 2 R's. So if these were all distinct objects or all distinct letters, there would be 8 factorial ways to arrange these. However, A is repeated 3 times, so I would have to divide by 3 factorial. And R is, there's 2 objects of R, so I would have to divide by 2 factorial. So this results in 8 factorial divided by 3 factorial, 2 factorial. So I'll just get out my calculator to do that. Having calculator issues. So 8 factorial divided by 3 factorial. Just typing that in my calculator. Anyways, trying to still work this out. Figure this out in your calculator, and hopefully yours works better than mine. All right, let's move on to the next example. See, what I really love in math is when you think that we're talking about permutations and combinations and stuff like this, and then somebody gives you an example in which has real-life applications. So here, the following grid lines represent the number of paths that April, presumably A, can go to Barb's house. Suppose that April can only travel in paths that are in a direction of east or north. Identify the number of possible different paths. So really, this is kind of odd, isn't it? I have this here, and I thought I'm talking about permutations and combinations. But here, I can know that I'm going to go east or north. I can't go south. But what's interesting is that no matter what path you take, you're going to have 1, 2, 3, 4, 5, 6 easts, and you're going to have 3 norths. Well, let me try that out. So north, east, east, north, east, east, north, east, east. Yeah, in fact, I'm always going to have 6 easts and 3 norths. So basically, I have a word that is north, 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 east, 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 east. So I have, it's very similar to the aardvark question, but now I just have 2 letters. So how many objects do I have? I believe I have 9 objects. So I have 9 objects. So 9 objects can be arranged 9 factorial ways. N repeats itself 3 times, so I divide out that repeating nature by dividing it by 3 factorial. E repeats itself 6 times, so I simply divide that by 6 factorial. So 9 factorial divided by 3 factorial, 6 factorial will yield my answer. So 9 factorial, just do this one quickly, I hope. Calculator work is never that quick. So 9 factorial divided by 6 factorial times 3 factorial will yield an answer of 84 different paths. And why is that? Because although we're following directions, we created this word thing. I hope that this helps out. A little bit of calculator work. If you have any questions, please ask.